My last video got cut off. I'm going to have to make this a little bit short. We simply find out what the temperature is for each of these states, and then we can quickly write down what the heat transfer is for this isovolumetric process, an isochoric process. Similarly, we can also write down the heat transfer to an object at constant pressure. That's the CPN delta T, where Cp is equal to 5/2 RT. So 5/2 nR delta T for constant pressure processes for a monatomic gas. And we can figure out what those are real quickly, right? We just simply need to go in and find what the temperature is at each of our 4 points. So that's going to be really useful. And then by using the first law, we can figure out what the internal energies are at each of those 4 points. And the very last question it asks us about is the efficiency of the cycle. So this is great, right? This is exactly what stuff we've talked about in class. The efficiency of this cycle is simply going to be whatever we get out divided by what we put in, right? How much are we getting out for all the work that we did? How much work are we getting for all the energy that we transferred in? So we look at the 2 points where we're actually transferring heat into it, which are these two right here, right? We have AB, we're putting gas or heat transfer in, and BC, we're also putting a heat transfer in. We can sum these two up real quick, put those in there. The net work that we are doing is the work of BC plus the work at DA. This is going to be a negative value, and we can evaluate that quite easily, right? This is going to be P2 times V2 minus V1